Welcome to another episode of Earth911's Sustainability in Your Ear. We're back to have another conversation with a changemaker working to accelerate the transition to a sustainable, carbon-neutral society. I'm your host, Mitch Ratcliffe. And hey, by the way, welcome to Season 3 of Sustainability in Your Ear. We just finished our summer hiatus and starting a very busy fall and winter of interviews, so I hope you'll stay tuned. Today, we're going to be talking about water because, water, along with air and land, is our most important resource. We need it to hydrate our bodies, to make much of what we eat and use every day, and we use it to carry away our waste. Treating wastewater instead of dumping it back into the environment is an inefficient process. 374Water, a Durham, North Carolina company, has developed a compact wastewater processing technology. It's called Supercritical Water Oxidation, and we're going to refer to it as AirSCWO throughout the show. Is a very compact version of water treatment facility. It fits inside, in the smallest case, a shipping container. The AirSCWO system can process industrial and community-generated waste of all sorts, from wastewater generated by communities as few as 6,000 people, or the equivalent industrial waste, up to systems that support 30,000 or 200,000 people's worth of waste. We're joined today by Nagar, who is CEO of 374Water. Their system does more than clean water. It also as you operate it, generates energy, industrial CO2, trinitrogen gases that can be used in manufacturing, distilled water, and minerals extracted from the wastewater. In other words, we can mine our wastewater for a lot of raw materials for the next generation of products. You can place these systems in combination. As I said, they fit in a shipping container and they can be stacked or added together to provide power and raw material for a variety of new uses. 374Water is publicly traded on the NASDAQ. You can find it under the symbol SCWO, and has reported rapid revenue growth over the past year, 6,958%, in fact, albeit from a very low base. They recently launched an Israeli subsidiary and sold the first municipal system to the city of Fountain Valley in Orange County, California. You can learn more about 374Water at 374water.com. Welcome to the show, Kobe. How are you today?
Hey, Mitch. Great to be here and great to open the third season. We obviously like the number 3. We have it in our name, and we are moving the third generation of the technology that you mentioned, and we're going to unpack that in our conversation. So great to be here.
Well, a whole series of things that are fitting together here. Let me start off with a simple question. How does the supercritical water oxidation system work? What does it do?
So, I want to go back and kind of explain two phenomena that are basically skipped in most school, which is the fourth stage of water. For a lot of people, water exist as ice, as liquid, or as steam. But what's really remarkable about water is once you start heating it up above its critical point, so above 374 degrees Celsius or 705 degrees Fahrenheit, and at high pressure, so around 221 bar or 3,200 psi, you create water, and in those conditions, water have an amazing property that are not discovered, not discussed in most school. And we are harnessing that phenomena. Again, that phenomena was discovered 200 years ago. We harness that phenomena in order to treat waste, and really using the properties of water in that unique space.
What happens to water when you heat it to that level? What is the critical point of water, and what is that fourth state?
So again, that critical point of water happens above 374 degrees C and 221 bar. And what's really unique about water in those conditions, water above its critical point becomes a good solvent for organic molecules. The same way that acetone can dissolve organic and plastic in room temperature. Water can do that in those conditions. And in a sense, water polarity is changing. So instead of becoming a good solvent for salts and mineral, it becomes a good solvent for organic molecules. And what we're doing, we are harnessing that phenomena of water and use the water as the catalyst and the media to treat waste. So we have organic waste, we have water in those conditions, and then we add an oxygen into the mix. So that's the oxidation part of the reaction. And once you do that, really magic happens. You can really mineralize any type of organic, any chemical or hydrocarbon that you can think of. You can mineralize it completely and create water, energy, and you end up with only the inerts, only those minerals, those salts at the end of the process. So it's a one-step process.
So you can run anything through this and get out the component elements as a result, in addition to power?
Pretty much anything can run through the process. What we are focusing on is treating organic waste.
Sure.
So those hydrocarbons, and it depends on the industry vertical that we're working in. Mm-hmm. Many applications for municipal waste, but also industrial waste, and it's give us the ability to look at waste differently. One of our mission is creating a world without waste. But what does that mean? That means that we no longer call waste. We actually look at that as the resource of the future. And that's what we're pushing into the industry for a long time. And for most people, the awareness about waste wasn't exist. For us, for most people, every time they're flushing their toilet or dumping their waste into their green bin, they tend to forget about it. And that's ending up either in a wastewater treatment facility or ending up in a landfill. And that's actually where the problem starts to begin.
So you're really saying that the raw material for the future is the stuff we've been throwing away for the past 200 years.
Yeah, exactly. It's waste, and again, I can go back to how do we got into this technology and why we're focusing on what we're focusing. We originally looked on the developing world. There was a project back at Duke University, was funded by the Bill and Melinda Gates Foundation, and the focus was how can we create a different type of technology that can actually leverage the fact that we have waste. And for us, the tipping point or the thing that we discover was when people are dumping their organic waste. In this case, it's either to a pit latrine or into a river. Right. They're actually dumping energy. And we did the count, basically a barrel of fecal waste equivalent to about 87 kilowatt hours. And in today's world, this is the amount of energy that you have in a Tesla P90. So once we got that, then the entire conversation about waste really changed, because now you have an energy source, you have a water source, and you have a mineral source that can help you grow food later on and use it as a fertilizer. So once you get that, and then we took a technology that was very much on the fringe size of science. Mm-hmm. We got a very successful value proposition, because waste is no longer waste. Waste is energy. Waste is water. Waste is mineral. And the fact that we can do what we do in a very compact form really help us to do those type of treatment at the source where you generate waste. And you win on both places. You win by harnessing the value of waste, but you also eliminate all the transportation cost and emission that you have from just moving waste, back and forth. So that's the type of future that we're pushing forward. Obviously it will take time, but that's the type of future I want to see for my kids.
So how much is, obviously, heating water to 374 degrees centigrade takes some energy too. How much energy nets out when you're done with the process? You mentioned a moment ago, I think 78 kilowatt hours. Is that's what's left over after you run a process?
Yeah. So again, energy is just changing form, right? We don't lose energy. We are converting the chemical energy that you have in the waste into heat. And what we are doing well in our process is really managing that heat. So we take the waste, we convert it into heat and basically treat it, and then use that heat to heat up all the inlet streams that goes into the system. So what you end up is a system that doesn't require any energy besides just the startup, which takes about 2 hours, and you're generating heat, and from that heat we convert it back to electricity, and that's again changing the game. And how do we look on waste?
So what kind of waste can you process? Obviously, we're talking about sewage in one case, but are industrial waste, what else?
So so we as society are generating a lot of waste. And the technology is very applicable for any type of chemical that is organic. So any carbon bond, or even nitrogen bond that have energy in it. So you can think about residuals from wastewater treatment, municipal waste, but also water that is contaminated with different organic, like landfill leachate, and industrial application where you have solvents and oils and materials that really don't have a good treatment right now, and this technology can do that. Most importantly, it can do that in a very ecological way, because when you treat waste in water, you don't generate those secondary pollutants that you generate when you incinerate those materials. So that's very important, and a big differentiation from what we're doing compared to incineration. And on top of that, we are 60% lower energy than those type of process.
So let me ask you about a couple of specific applications that I was curious about as I read about it. One is processing food waste. So I assume you take the food waste, mix it with some water, and run it through the system. Are we talking about any type of food waste? Could this potentially replace a landfill as a way of processing food waste?
Yeah. So the short answer is yes. Believe it or not, a lot of the foods that we consume contains a lot of water in them as is. So it looks like a solid form, but most food waste are actually 70% to 80% water, which is very applicable to the type of slurries that we can treat in our system. And again, food waste is another type of waste, but we can also treat plastic and really complex waste. So again, think about any hydrocarbon, any carbon chain that or a man-made chemicals can be processed and treated in our treatment units.
The other thing I wanted to look into a bit is PFAS. You can process per and polyfluoroalkyl substances, forever chemicals. A lot of people are only beginning to become aware of them. But you can take these out of water and other media. could this be a way for us to address some of the growing problem of PFAS showing up in the environment, whether it's in our drinking water or processing runoff from, say, airports, where it's used as a flame retardant?
Yeah. Absolutely. So first of all, I think, to talk a little bit about PFAS, for us and for a lot of people, it was very, very eye-opening that the way that the future of our drinking water really depends on the way that we treat our waste. And PFAS is really, really emphasizing that the current treatment technologies are very limited to treat non-biodegradable or man-made material, which we're generating a lot of. So what's also unique and very and part of our success is we are almost the only technology that can actually break down and destroy those PFAS into a level of mineral. Really differentiated on that front is using the supercritical water oxidation. It creates the most oxidizing environment, and in those conditions, you can actually break down those carbon bonds, but you can also break down those carbon fluorine, those CF bonds that are very hard to break in traditional technologies. And we have done that, couple of times for different type of waste, and we're very proud that our technology can treat the simplest but also the most complex waste like PFAS.
That's really interesting. I hadn't really made the connection that because of you're using high temperature, you can also break down these elements that are essentially high temperature products. And so fascinating. Okay, so PFAS could be not just collected, but processed and removed from the environment. Literally, they don't exist anymore when you're done with your process.
They don't exist. Again, the PFAS, the carbon bonds are being broken down. So we actually generate energy from breaking those bonds, and then the fluorine atoms is actually precipitated out as a fluoride salt, and that's a safe salt. That's for most part calcium fluoride, which is an ingredient that you have in your toothpaste. So it's really taking one of the most challenging waste and convert it into something that you can use later on.
So could you use this, for instance, to treat a water supply? Could you roll in one of the AirSCWO devices and clean up a water supply using this?
Yeah. So it depends on how concentrated those waste. In order to maximize the value for our equipment and the capex, what we're doing is we tend to concentrate the waste as much as possible before we feed it into our system. Mm-hmm. And that gives us the ability to treat a higher throughput of water if it's diluted. The same thing is treating different media that have absorbed PFAS. That's a big winning application for us. So when people are talking about treating drinking water, they usually do that with a granulated active carbon or an ion exchange media or an RO, reverse osmosis. Every one of those technologies are actually concentrating the waste, either on the media or the concentrate from the RO process. And this is the type of waste that we like. We like it to be concentrated, and then the treatment is complete on the back end. So really opening more ability to treat a variety of waste.
This is fascinating. I want to take a quick break. We're going to get back after a quick commercial. Folks, stay tuned. We'll be right back. We're back to continue our conversation with Kobi Nagar. He's the CEO of 374Water, which makes a remarkable water processing technology. So, Kobi, this is fascinating. What are the environmental impacts of actually manufacturing your product? Are there do you need raw materials, rare earths, or other kinds of things that we have to mine in order to make a 374Water device?
So Mitch, great question. So I want to unpack it a little bit
Go for it.
because what we're doing is we're building systems that are lasting for a long time.
Right.
So yes, there is obviously the manufacturing of those units, and you can imagine those units as a combine of different heat exchanger and different metals that are used to treat the waste. The way that we differentiate ourselves from the rest is the technology really allows us to have a very compact system. And compact system means that we use less material to build it. And we also are not creating the impact. We also creating the positive impact to the environment. Because for a lot of people, when they talk about waste, they're only focusing on the CO2 emission during transportation. What we
Right.
have realized that when you leave those type of organic waste in a landfill, what you're generating most of the time for most of the waste is methane. And methane is about 86 times more potent than CO2.
Mhm.
So when we have done our calc about how much CO2 we actually mitigating per ton of waste that we treat, we got to about 6 tons of CO2 equivalent for every ton of waste we treat. And it's really a big impact to that industry, which is for most part going under the radar.
So, just like the carbon footprint of any product, the longer you use it, the more return you're going to get. But it sounds like you break even pretty quick.
We haven't done the calc on how much carbon emission we're consuming during the fabrication. That's something we have in our pipeline to do.
Mhm.
But we believe that the return on investment is very short, and creating a positive impact. It's also offsetting the cost or the carbon footprint from using a traditional technologies. And the fact that we are compact really gives us the upper end on that.
So let's talk about a few other applications that I read about as I was doing research on the product. You speak about using these around concentrated animal feeding operations, CAFOs, where thousands of cattle are fed and slaughtered. How many of these devices are needed to process the material from one of those CAFOs? And is this potentially something where a CAFO could become environmentally neutral if we had a few of the AirSCWO systems attached to each?
Yeah, absolutely. Ag waste, for whole, is one of our prime markets. And when we when we are looking on waste that animals produce, and again, I'm in North Carolina, so North Carolina is very big on animal waste and CAFOs. The ratio that we have is very applicable for those CAFOs, for the medium to large scale CAFOs. So our smaller scale system is actually designed to treat waste from about 6 to 10,000 people. So it depends on the type of animal. So I don't know if you know, but pigs are generating about 3 times as much waste as people. Chicken are about 1/8. So it gives you a flavor to the size of the CAFOs that we can cater with our small system, and obviously a bigger system have better economics as well. So definitely a prime market. We can also leverage the fact that we're treating the waste from those CAFOs and providing heating back to heat up those industrial factories.
A closed loop. I mean, that's really interesting. We're talking about integrating the waste into the manufacturing process so that it becomes an input rather than an output. But at the same time, you're also talking about offsetting a lot of the energy use that we typically associate with large-scale production simply by processing the waste. We're mining the past to make the future. That's fascinating.
Yeah, again, looking at waste differently. Look at that as the resource. Look at that as energy, as water, as minerals. For the CAFOS itself, it's even the greater circular economy is also using the minerals that are end up in the process as a fertilizer. So you really create that circular economy around waste.
Now, the other thing that there are a couple others I wanted to ask about, but solid waste. I don't normally associate solid waste with something that I could process using a water processing system. How would remediating solid waste work using an AirSCWO system?
So, by the way, we call it SCWO. So we are SCWOifying the world the same way people are electrifying the world. So SCWO, that's the short.
Okay,
short
let's SCWO.
Great. So the essence of that is having SCWO applicable for solids, but we cannot really feed solids as is into the system.
Right.
So what we do is we macerate solids and then feed it as a slurry into the system, and other co-treated with a different, more dilute waste. And one example that we like to give is we actually use and treat residual plastics from a recycle facility together with municipal waste or together with landfill leachate, and really using the value that those plastic have in terms of their energy calorific value to co-treat different type of waste that are very dilute or don't have those calorific value in them. So that approach of mix and match a couple of wastes together is very beneficial for reducing the operating expenses, the OPEX.
So in some sense, a landfill could become a self-sustaining, economically self-sustaining and power self-sustaining operation.
Yeah, to me, the future, and every time I visit in a landfill, people will say I become a sad person. Because when I visit in a landfill, I'm saying for most part, we as society weren't really taking waste in consideration. We dug a big hole or pile it and hope for the best. In my future, there aren't any landfills. There aren't any incinerators. Everything is being treated where it's being generated. And I mentioned the fact that our system is compact. So, just to get an appreciation for that, we are about 1,000 times smaller, so 3 orders of magnitude smaller than any biological-based process. And that really gives you the ability to miniaturize the technology and distribute that in a decentralized way. So the business model and the concept that we have today, which is let's build the biggest wastewater treatment facility or the biggest sorting, can be actually changed. And future is more decentralized approach where the community is actually getting the benefit for treating the waste.
So this is a question I've asked a number of guests over the years. Could we treat our landfills as natural resources in the sense that we could go back and mine what's in the landfill? You process leachate from landfills, for instance, but could we treat the entire landfill as a raw material for future stuff that we want to make?
I think we'll have to. It's just a matter of time. right?
Yeah.
For most part, the minerals and resource that we have in this planet are very limited. So right now we are considering landfill as a viable solution, but you see the shift. So
Mhm.
we used to just have a big hole in the ground, lined it or not lined it, and then pile everything into one big hole. And the shift that happens in the last 2 decades, we actually are separating the type of waste, and
Right.
we try to repurpose them, reuse them as much as possible. And there are some good examples about companies in that space that are changing. The concept of landfill still exists. In my future, it should not exist. We should figure out a way and incentivize the manufacturers and the producers of the consumed good, to really take into account the end life of the product, or how to reuse it again for the benefit of society.
So the question that comes to mind for me then is, how do we finance this? Your system relies on an immense depth of partnering capabilities. Are there different ways that 374 Water can work with communities, even nonprofits or corporations, to finance the extraction of value from the waste that they have?
Yeah, that's exactly what we're doing. We have strategic partners that we're working with, that see the benefit. We're not doing that from we're doing it from pure economics.
Are
Our
those investors, or are those communities that are deciding they want to make this change?
It's more of a commercial strategic partners that
Okay.
wants and push to see our future. Again, at that point in our life, our cost is actually lower than traditional treatment technologies.
Right.
So it makes the argument much easier. We don't need to be at premium. We are at the place that solar industry have been 5 years ago, right? It's equivalent. Now solar is cheaper than um, traditional energy manufacturing, and we predict the same future for SCWO as well.
So paint a picture for me what the world might look like in 2030 if SCWO is widely deployed. Where do you want to be in 2030?
So I'm joking for everybody that once we enable that in the different market verticals that we are working on, nobody will want to go back to the traditional treatment that exists today. It's outperforming in every category, and most importantly, it's environmental.
Mhm.
So the future is very bright. I look at that as, we are in a sense landing on the moon, and in a couple of years there are going to be a lot of astronauts or squarnauts that will want to do what we're doing.
So, this is really fascinating, Kobe. I mean, and inspiring. How can folks keep up with what 374 Water is doing? And if they're interested in getting their community involved, how can they talk to you?
So we love to talk to people that are seeing and want this future to happen. We are again we are broadcasting ourselves as a social impact clean tech company. The reason I founded the company is for the selfish reason that I want my kids to have clean drinking water, and that's what we're pushing. So we're very active on LinkedIn and on our website. And again, we're not shy of partnering with anybody.
Well, Kobe, I want to thank you for taking time to talk with us today. It's been fascinating.
Absolutely, Mitch. Really appreciate the opportunity, and glad to collaborate on this.
We've been talking with Kobe Nagar. He's the CEO of 374Water, and you can find out more about 374Water at 374Water, no dash, no space, 374water.com. Do check it out. What we just heard is probably the most on point response to the question, can we use our past waste to fuel and build the future? The past is prefaced. We have wasted material. We've thrown it away after barely using it even once for 225 years since the beginning of the industrial era. And in some sense have accumulated the raw materials for powering the future, making the next generation of products, and ultimately having those products become the raw material for every generation of products. What we have always talked about, the circular economy. And these basic technologies are going to underlie a transformation of our society. So, folks, if you're interested in learning more, go check out the site at 374Water, but also contact your solid waste management team in your city. Contact the organization within your business that processes waste. They may be paying to send this stuff somewhere else where it could be turned into the next generation of the stuff you make. I hope you'll take a few minutes to share this podcast and all the others that we've done. You can find us on Apple iTunes, Spotify, anywhere you find your favorite podcasts. We're there, and I hope that you'll share this idea and all the others that we've done with your friends, family, and coworkers. This is Earth911, Sustainability in Your Ear. I'm Mitch Ratcliffe. We're going to be back with another innovator interview soon. As I said, we're just starting off season 3 of the show. Stay tuned. It's going to be a lot of fun, and you know what? We're making progress here. Every time we talk to somebody, we learn more about the fact that the future is entirely achievable, a circular future. We'll be back soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.